Hey all, I'm Rishit Bhushan and today I'm here to present a project Kompress AI. So let's look at the problem statement. Basically, when people want to compress the AI models, like make them smaller or faster, it usually ends up being this really messy manual process. You need different tools for different compression techniques, and every device like CPU, GPU, mobile needs their own setup. What we're trying to solve is that hassle. Our project is like a one-stop pipeline that handles all kinds of compressions based on whatever constraint the user has, whether size, speed, or accuracy. The best part is flexible across famous formats like ONNX or TFT Lite and scales from tiny models of microcontrollers to huge transformers. So yeah, the goal is just to make compression simple, smart, and super adaptable. This is the website that was made by me. Let us look at this in action. So first I have to start off login. So I've logged in. So this here is my account, and here this is the home page which shows basic detail. Like on this particular account, I have submitted 4 projects, which is displayed here, and a graph. Now, while the other sectors like how it works, Compress project, live dashboard, and documentation, today we'll be looking at Compress project. So on this page, Compress project, the user is required to fill information based on his project. So let's start. Project title and description. We'll give a project description, submission. That should be enough. And deployment target here will be selecting CPU, basically based on the user's preferences. This can be selected on where he wants to deploy. For today, we'll select CPU. We have sklearn model. We'll be selecting the second option, which is model.joblib plus model architecture. And here we are required to upload a file. If we select a model one next, we have to upload that, but we'll be uploading this today. So let's upload this from a file from a computer. We have the model.joblib and now model.architecture, which is a Python file. Here we go. Now dataset bundle, this will be a zip file regarding the necessary contents of the project. Evaluation script, which is again a .python file. Evaluation script. Now preprocess pipeline, for today we'll be selecting preprocess.python, while there are other options or the formats supported as well. Let's upload our preprocess file. Here we go. And optimization level, this basically has 5 sectors, which is extreme, balance, latency, size, and accuracy. For today we'll be selecting size, which means that the project will be, or the AI model will be compressed at most, so it will be at its lowest size that it can exist in. So let's select size. And now security and data consent, here basically these are consent that that the user will be giving us based on that they're allowing us or giving us consent to process the data. After checking these 2 boxes here, let's submit the start compression or submit the project. Here it says submitting, and here it shows project submitted successfully. So now basically we have used Supabase as our backend, and all the data is being stored there. Let me show it to you. Here in Supabase, these are all the projects that we have uploaded as a test, and here you can see my project just got uploaded, Bolt Hackathon submission. You can see that all the files or all the necessary parameters that we added here, added in the project are seen. So description, submission, model file URL, these are the URL of the files we have uploaded, dataset file, evaluation script, etc, etc, etc. And then here we have a title, which is Bolt Hackathon submission, like we mentioned, deployment target, CPU, optimization level, size. Okay, so now basically all the data of the user or the project files are being stored in Supabase. From here, the project submission of the URL of the file are going to the AI model, which is compressing and giving the output on the website. So on to Ishan, who will be explaining the AI part.
My name is Nishan Goodbille, and I'm going to be explaining the back end of this project. So in this project, we've trained a a classification model that will be able to tell what kind of 3-step process we're going to need to use to compress the user's model. So now what it takes is the device it wants to run on and the purpose, whether we want to decrease the size or accuracy. So right now we have a iris model over here. This iris model is trained off the iris data set. So this data set is pretty small, hence the accuracy of the model will be larger, but we want to reduce the size. So using this, we've basically decided for the purpose we want to run it on our CPU, but we want it to be size focused. So what we do is, in our config file we specify that, obviously it will come from the website, we specify that the purpose is the size and the device is the CPU. Then using that, we're able to load our prediction model, tell as to which purpose it is, get a prediction. So our prediction right now is that it needs to be pruned, which is the correct step, as it needs to be reduced in size. After we prune it, we dump our prune model, and we've got a perfect model right here that's pruned. Now as you can see here, the iris model is around 3 kilobytes, and a prune model is around 2 kilobytes. So this makes a massive difference when you're training proper models that are huge and bigger in size. And oftentimes it becomes very tough to decide what steps you need to take, and this process will incredibly streamline it and help a lot.